this is your same example, basic box,
Yes.
one box. So could you please open your terminal?
Yes,
Let
Yes, the
me
base.
take a control and I will do it. Could you please allow me to control it?
Yes, I've allowed.
Okay. So, but I'm not able to do it. Mm, yeah, now I can do it. Okay, you go here and yeah, you are already in the Topaz, so we can go here and then you just okay. Maybe this shortcut doesn't work for me, so I'll go with this. So you see, you go to PWD, it says that you are in the home directory, and then you
Yes.
do ls. It will tell you what are the folders you have. You go to Topaz, uh, Topaz. Oh, the system stuck. Could you please? Yeah, Topaz, and enter. CD, uh, CD examples. CD basic. Okay, and now type ls just to see the examples. Okay, perfect. And now you do pwd. Clear, clear, type clear. Oh, seems like I'm not able to see it. So clear, actually it's clear screen or clear. Yeah, type clear and space. Yeah, it's there. Now type pwd. So it tells you that you have to go two steps down. So try to do it that way. Now type bin. No, no, not this way. Continue typing the same way, like go two steps down. Yeah. No, no, no space.
No space.
Yeah, and don't hit enter at this moment.
Oh, okay.
Um, Now type bin, then slash, and then topaz, space, one box, dot txt. Yes, enter. It should run now. Yep, here you go.
Okay.
So now you have your graphic user interface. It shows your geometry and you can interact with it. Like you can try to check it and rotate it. And actually, it is there are several type of graphical user interface that you can use here. And maybe we can have a separate session on that because your graphical user interface is not as user friendly as mine one.
Yes.
It is because of some of the drivers that or yeah, some of the drivers that we install or the um, graphical user interface that we install. So don't worry about that. It's not compulsory for you right now. And
Okay.
you can control the zoom in and zoom out um, of your example or of your geometry through your mouse.
Okay.
You can just scroll in and scroll out. So this way you can control. But the important thing right now for you is to see your geometry and to know how to look at your geometry through this commands and through graphical user interface. Okay. But like you can do one thing, for instance, I show you. If you don't want to, when we run our simulations, we generally don't want to check, let the user, the computer or the yeah computer to show our geometry. We want to make it fast because it takes time to load the geometry. So
Okay.
what you can do is you can just use hash, and this way it will not show your geometry. And now if we run our example, you see there is nothing and everything finished within a second.
Okay, I'm sharing my screen so I can't see yours.
Oh, okay. Sorry. hmm Yeah. You see, I commented this line.
Comment out.
You Yes, you just use a hash to comment out it, and this way it will comment out everything related to
Yeah.
view graphical user interface.
Okay.
And now if I run like I do clear, oh, okay. Yeah. So if I run now, you see it finished within a second. It didn't take much time to load the geometries and everything.
Yeah.
So generally, it is a strategy to speed up the running simulation
Okay.
for
Okay.
running the simulation. Otherwise, you can allow loading of the geometry, so it takes more or less 4 or 5 seconds. But we don't. For small geometries, that's not a worry. But when you have a complex, huge complex geometry like a linear accelerator, a simulation setup, maybe you don't want to spend that time, because for me it takes time sometimes for complex geometries like humanoid phantom. It may take like half an hour to load everything.
Okay.
But it is good for initial testing purpose, but when you run a simulation, you don't want it to show to you. So it's okay to comment out such things. Okay.
Okay.
So we already checked the simplest example of Topaz with the my box. So one box. And now let's see these three things that are important for us. So let's see this. You see this thing, what it has done is include one box. So this
Yes.
is a strategy to include one of the files. So maybe you don't want, sometimes you have like three things. For instance, here in one box, there are three things. One is your geometry, another is your physics, and the third one is your
Graphics.
graphics. Yes. And when you have like these are easily visible in one screen, and so there is not a problem. But if you go to big examples or our own example, I show you where it is. Yeah, the best training. Yes, you see it is very big, and I added it into a single file. And
Yes.
sometimes it's not a good idea to keep things like this or keep your simulation parameter file like this. Maybe you want to divide it into two files, and then you simply say include file, and you put the name of the file. So you put physics in one file, geometry in another file, and then the scoring parameter or other kind of things in other file. Maybe you will have different files to manage, but you will do it. You will not be in trouble like there is too much text to manage and it's hard to find where is the error. So you will able to find and you won't be scrolling down and up again and again for your in your file. So this include file strategies there, and you can include two or three files. So that is not a problem. Okay, and
Okay.
and this is simply the rotation they have done. We already tested it. So actually, initially they set rotation x to 0, but in the new file they made rotation x to
45.
45. So now if you run this, we will get the same thing what we got initially for our one box. When we rotated it, one box rotated. You see, it is
Yeah.
rotated along x direction by 45 degrees.
Yes.
Okay, now let's check the
Translation.
yes. So you see, it
Yeah.
it automatically inherited value. So inherited value is like you define your box. It Topaz automatically defines your world volume, and it takes the inherited value is the world volume. Its coordinate system according to the world volume. So it takes that it this value what it's taking is it defines inherited value and then it subtracts that zero point 0.5 meter out of it. uh
Mm.
nope, it's no, it's not like that.
Multiply.
Yeah, it takes the coordinate according to the world volume and then it multiplies it with the minus factor of minus zero point 0.5. So it translates along the x-axis, but by this factor, not by us. Like we were defining a particular value, like translate by 2 meters or 1 meter, but here it is like it takes the value from the according to the coordinates of the world volume, and then it they are doing this kind of translation. But you don't need to make it that complicated. You can specifically define like I want to translate 2 meters and that's it. Okay,
Okay.
let's run this one also. Hmm, where it is translated. Actually, I'm not able to analyze it because it says translation along x-axis. Yep, you
So it
see
got
the,
translated.
it is a very small
Very
translation.
small. Yes.
Yes, if
Got
you
his
see
point
the
from
length
there.
of it, yeah. So yeah, it is translated, but it's not clearly visible. If we make it very big, huge, it will we will be able to see like yes, the box was translated, but here it's not clearly visible because the translation is very small. Okay, so we finished with the three things: translation, rotation, and basic one box. Now we go to our main one of the concept that I want to share it with you is the parallel worlds. So what is parallel world? Let's first run this and we'll see what are its components and then we'll check what it exactly mean by parallel world. Okay.
Okay. Okay.
It is like very important concept that you may need, and it is generally they prefer not Topaz community or the developers say that try not to use this thing as much as you can because it also like reduces the efficiency of Monte Carlo code to speed up your calculations. So if you don't need parallel geometries, don't do it. Okay. So
Okay.
let's here is our example. So there is sphere, and inside it is a box which is kind of voxelized or made up of grids. Okay.
Okay. So if I can attempt explaining, the parallel world would mean that since you have already set up your world to be a box, it will set other boxes parallel to the main one. Is that what it
Uh,
means?
yes, yes, exactly. Or maybe,
Okay.
for instance, like you are performing a brachytherapy experiment or simulation of a brachytherapy experiment, and you have a patient images. Okay. So you want to define a phantom out of patient images, and then you want to define your source in the form of applicator, and then you want to send a seed inside this applicator. So you have three level of geometries. One is the patient image, one is the patient images, then is the applicator, and then is the source. So
Yes.
they are inside one another. So you can I you, and there is like in Topaz or any Monte Carlo code, there should be no intersection between the geometries. Like they should be separate. Like
Okay.
here, the sphere should be separate and these boxes should be separate.
Okay.
There is no concept of like intersection between these box components. So if you want to define that complex geometry with the patient images, the applicator, and the source, you have to use this kind of parallel world concept. In that case, it will allow you to place like here the sphere inside the box, and like the pink box inside the blue box.
Yes.
So this is parallel world concept, and maybe you will need it. Like I have used it in for our workshop. That's the reason why we are discussing this.
Okay.
Okay.
All right.
So now let's check the input file. You see, it is not that big, but it is big. So maybe you want to define three separate components, like um, and with the three like with the box in parallel worlds here, and so they have
Yes.
defined
Okay.
three box in mass world. You see here they separately define the world volume, and you can set it to invisible. So by setting it to invisible means it will not show up to you in on your screen, and because you don't want to check it, all you want to check is that all your defined components are within the world volume or not. Okay.
All right.
So here the type, the parent you must define for every volume. So the world volume doesn't have any parent, but any other volume, whatever you define for your simulation, they should have the volume parent. And if you are not using the parallel world concept, then or if you are using, then mainly it's the world volume that is parent. If no one is the parent, then you set the parent to world volume. Okay.
All right.
Now, similarly, here is type, and type is TS box, but for sphere, it is TS sphere. Now, there is similarly X, Y, Z half length. So it's 779, and here it's the same. Like that's the reason we see the boxes mm, like intersecting or overlapping each other. And here for sphere, it is like armax. In this they haven't used the armin, so it is automatically set to 0. And yeah, and there are other parameter for sphere, like I show you. Um, okay. TS sphere. Where should I? Yeah. Yeah. Let's go here. a sphere. So yeah, mm, you see here, sphere, not here. Why it's mm, yes. So
Okay.
generally, when you define a sphere, you should
Maximum
define
radius.
maximum radius, minimum radius, d phi, and uh, d. Yes, s phi. Yep. Let me show you what it exactly means. I just copied it and we put it here. Okay. And we name it sphere.